Good morning, students. Today we are going to start the new chapter. This is chapter number 30, Nuclei. Right? So, first of all, we should know that what is the composition of nucleus. Actually, nucleus is made of neutrons and protons. Right? So, every atomic nucleus except the hydrogen has two types of particles, protons and neutrons. The hydrogen nucleus contains only one proton. There is no any neutron, right? That is 1H1. Proton is the fundamental particle with charge plus 1.6 in 10 to the power minus 19 coulomb and mass 1.67 into 10 to the power minus 27 kg. It is much heavier than the electron. The smallest mass particle of the atom is electron and its mass is 9.1 into 10 to the power minus 31 kg. Whereas neutron is also the fundamental particle with no charge and the mass 1.675 into 10 to the power minus 27 kg. It means neutron is more heavier than the proton. But the mass of proton and neutron is approximately equal to each other. Right? Now, atomic number. Atomic number of any nucleus is nothing but the number of protons within the nucleus. Right? So, the number of protons in the nucleus of atom is called atomic number. Right? Atomic mass number means the number of nucleons in the nucleus, means number of protons plus number of neutrons. Right? Mass number means number of neutron plus number of neutron, and combinedly protons and neutrons are called nucleons, means the number of nucleons is atomic mass number. Now, atomic mass unit. This is called unified atomic mass unit. This is the smallest unit of the mass. Now, it is defined as atomic mass unit or unified atomic mass unit is 1/12 of the mass of one carbon atom. One atom of carbon 12. Now, see, 1 mole of carbon have the mass 12 gram, right? So, it means n carbon atom have mass 12 gram. It may be written as 12 into 10 to the power minus 3 kg. We are converting this gram into kg, right? So, n carbon atom have mass 12 into 10 to the power minus 3. It means mass of one carbon atom should be equal to 12 into 10 to the power minus 3 divided by n. N means Avogadro number. So, 1 AMU or 1 unified atomic mass unit should be equal to 12 into 10 to the power minus 3 divided by n. Now, we are dividing this factor by 12. So, 1/12 of one carbon atom mass is unified atomic mass unit. When we calculate this one, we get the value 1.66 in 10 to the power minus 27 kg. So, one atomic mass unit is equal to 1.66 in 10 to the power minus 27 kg. This mass is approximately equal to mass of proton or mass of neutron, right? Means the mass of proton is approximately equal to 1 U, right? Now size of nucleus. The size of nucleus was calculated in chapter number 12 with the help of Rutherford experiment, that is called 10 to the power minus 14 meter order. One of the topic in the chapter atomic atoms, we have read the nearest approach of alpha particle to the golden nucleus. Now size of nucleus, first of all, nucleus does not have sharp or well defined boundary. Nucleus is always spherical. So the radius of the nucleus may be given as R is equal to R naught e to the power 1 by 3. R naught is constant and A is mass number of the nucleus. Right? Now the radius of nucleus is a range from 1 femtometer to 10 femtometer. Femtometer means 10 to the power minus 50 meter. Right? See, the volume of the nucleus is 4 by 3 pi r cube. Right? Since as per the liquid drop model, the shape of the nucleus is spherical. It means the volume of sphere is 4 by 3 pi r cube. We can substitute the value of r over here, so we can get 4 by 3 pi r naught cube a. Right? It means V is directly proportional to A. It means as the mass number increases, volume of the nucleus also increases. Right? So we can write V is directly proportional to A. Clear? Now next thing is nuclear density. Density means mass by volume. Right? Now the mass of the nucleus is AM. This is mass number, and the mass of the nucleus is equivalent to AM. So we can write it as A into 1.66 into 10 to the power minus 27 kg. So this is the mass of nucleus. Now see, the volume of the nucleus is V is equal to 4 by 3 pi r cube. Now we have to substitute the value of R. So we can get 4 by 3 pi r naught cube into A. This is the volume. Now we are going to calculate the density. Density is nothing but mass by volume. So we have to divide mass divided by volume. So we can get this value. Now the density is independent of any mass number. Right? There is no A. It means nuclear density remains always constant for all the nucleus. It means the nuclear density for hydrogen, for helium, for any other nucleus have same value. It means nuclear density remains always constant. Now we can make discussion over the nuclear density. The nuclear density does not depend upon mass number, so all the nuclei possess nearly the same density. It means nuclear density of all the nucleus is same. The nuclear density has extremely large value. Such high densities are found in white dwarf stars, which contain mainly nuclear matter. The density of nucleus is very high value. Now see in the previous slide, the value of nuclear density is order of 10 to the power 17 kg per meter cube. So nucleus have such a large density, right? Now third one, the nuclear density is not uniform throughout the nucleus. It has maximum value at the center and decreases gradually as we move from the center of the nucleus. For example, this is the nucleus. The density is very high over here. Density is slightly smaller than center. Now it is decreasing as we are going away from the center of the nucleus. The nuclear density is not uniform throughout its volume. The nuclear radius is the distance from the center of the nucleus at which the density of nuclear matter decreases to 1/2 of its maximum value at its center, right? So these are the points related to the nuclear densities, right? The nuclear density remains always constant, right? For today, this is the all about for this lecture. Now we will go for the next lecture on next day. Thank you very much.